February 19th, 1945. The black volcanic sand of Iwo Jima. A marine tank crew watched through their periscope as Japanese machine gun fire tore apart another flamethrower team attempting to approach a fortified pillbox. The portable flamethrower operator had made it within 20 yards before enemy rounds found their mark. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. It was the fourth team lost that morning. The lifespan of a Marine wielding a backpack flamethrower on Iwo Jima averaged 4 minutes. Inside the M4A3 Sherman tank, the crew prepared a different kind of assault. This wasn't a standard Sherman. Through the 75mm gun barrel protruded not artillery, but a flamethrower nozzle capable of projecting napalm-thickened fire across distances that would have seemed impossible just months earlier. The tank they called a Zippo, the weapon Japanese soldiers feared more than any other in the American arsenal. The question this story answers is not whether flamethrower tanks were effective. The question is how American engineers, working against impossible deadlines with makeshift equipment in a converted warehouse in Hawaii, created a weapon that would fundamentally change the nature of Pacific warfare and make the Japanese fortress of Iwo Jima vulnerable for the first time. The mathematics of death on Iwo Jima were simple and brutal. 8 square miles of volcanic rock, 11 miles of reinforced concrete tunnels carved into the island's interior, 21,000 Japanese defenders who had spent an entire year converting every cave, every crevice, every geological feature into a fortified killing position. The American intelligence estimate suggested the island would fall in 1 week. The actual battle would consume 5 weeks and claim nearly 7,000 American lives. The Japanese commander, Lieutenant General Tadamichi Kuribayashi, understood what was coming. A veteran with 3 decades of experience descended from samurai stock, Kuribayashi had transformed Iwo Jima into something unprecedented in military history. Not a conventional defense line that could be breached, but a 3-dimensional fortress where every position supported every other position, where tunnels allowed defenders to reoccupy bunkers that had just been cleared, where the island itself had become a weapon. The above-ground fortifications were merely the visible portion of Kuribayashi's design. Hundreds of hidden artillery positions, machine gun nests camouflaged into the volcanic rock, mortar positions firing from reverse slopes where they couldn't be targeted by naval bombardment. The underground network connected everything. Barracks 75 feet below ground level. Command centers insulated from the heaviest naval shells. Storage facilities stocked with ammunition for a battle Kuribayashi knew would be his last. In his letters home, Kuribayashi wrote plainly to his wife that no one on the island expected to return alive. Each Japanese soldier received explicit orders to kill 10 Americans before dying. The calculation was strategic. Japan couldn't win the battle for Iwo Jima, but the cost they extracted might make America reconsider the invasion of the home islands. American planners understood Iwo Jima's strategic importance with equal clarity. The island sat directly on the flight path from the Marianas to Japan. Japanese fighters launched from Iwo intercepted B-29 Superfortress bombers heading to strike the Japanese mainland. An early warning radar installation gave Tokyo over 2 hours advance notice of incoming attacks. Damaged bombers returning from raids on Japan had no emergency landing site, forcing crews to ditch in the Pacific or attempt impossible flights on failing engines. Capturing Iwo would eliminate the fighter threat, provide that emergency landing field, and allow P-51 Mustang escorts to accompany bombers all the way to Japanese cities. The island's value justified significant casualties. What planners failed to anticipate was the inadequacy of conventional weapons against Kuribayashi's fortress. The pre-invasion bombardment, while impressive in scale, achieved limited results. Naval artillery and aerial bombs pulverized the island's surface, but barely scratched the underground network. The craters left behind actually provided additional cover for Japanese defenders. American commanders had requested 10 days of heavy preliminary bombardment. They received 3, and weather impaired even those limited strikes. The conventional military wisdom for amphibious assault relied on overwhelming firepower to suppress defenses, then infantry and armor advancing in coordination to capture objectives. Iwo Jima defied this doctrine completely. The Japanese didn't man defensive positions on the beaches to contest the landing. They waited until Marines had moved inland, committed to the attack, then opened fire from positions that artillery had failed to destroy. The American infantry weapons designed for conventional warfare proved inadequate against cave entrances and reinforced concrete. Rifle fire couldn't penetrate firing ports. Hand grenades often bounced off without entering bunker openings. Even direct hits from tank guns frequently failed to breach the heaviest fortifications. The Marines needed a weapon that could follow fire around corners, penetrate openings too small for explosives, and generate heat sufficient to kill defenders deep inside protected positions. The portable flamethrower represented one answer. The M1A1 backpack flamethrower carried by Marine infantry could project napalm approximately 50 yards when conditions were ideal. The weapon proved devastatingly effective against Japanese positions, reaching into caves and bunkers where conventional weapons couldn't touch. The psychological impact on defenders who faced burning death in enclosed spaces was profound. But the cost of operating portable flamethrowers was equally profound. The operator carried 70 pounds of equipment on his back, 2 tanks of flammable liquid, and a third tank of compressed nitrogen to propel the fuel. The weapon made him instantly identifiable to Japanese snipers. The bright orange flames marked his position. The close range required for effectiveness, typically 20 to 40 meters, exposed him to concentrated small arms fire. The cumbersome equipment slowed his movement precisely when speed meant survival. On Iwo Jima, the statistics were horrific. One Marine flamethrower battalion sustained a 92% casualty rate. The average operational lifespan of a flamethrower operator was measured in minutes, not hours. Marines watched their fellow flamethrower teams cut down, attempting to approach the same positions they would be ordered to attack next. The courage required to pick up that weapon, knowing what awaited, exceeded normal human calculation. The fundamental problem wasn't bravery. The fundamental problem was vulnerability. A man carrying explosive fuel on his back, moving slowly across open ground toward hardened positions defended by soldiers who understood that killing the flamethrower operator was their highest priority. The weapon worked brilliantly when it reached its target. The challenge was survival long enough to employ it. American military doctrine emphasized combined arms warfare, using different weapon systems in coordination to maximize effectiveness while minimizing casualties. Artillery suppressed enemy positions. Tanks provided mobile firepower and protection. Infantry secured ground and cleared positions. The system worked when all components functioned as designed. On Iwo Jima, the system was failing. Tank guns couldn't breach the heaviest bunkers. Artillery couldn't reach positions protected by overhead cover. Infantry without flamethrowers couldn't clear fortified caves. The portable flamethrower worked but killed its operators, faster than they could be replaced. The Marines needed a weapon combining the protection of armored vehicles with the bunker-clearing capability of flamethrowers. They needed a flamethrower tank. The concept wasn't new. Multiple nations had experimented with vehicle-mounted flamethrowers during World War I and the interwar period. The results were mixed. The German Flammpanzer variants of the Panzer II and Panzer III were discontinued due to unsatisfactory performance. The fundamental challenge was range. Flamethrowers typically projected fire less than 150 meters, making them virtually useless on open battlefields where anti-tank weapons could engage at greater distances. The Pacific Theater presented different conditions. The close-quarters combat required to clear fortified positions meant short range wasn't necessarily a disadvantage. The psychological impact of flame against defenders in enclosed spaces compensated for tactical limitations on open ground. If American engineers could mount an effective flamethrower on a tank with adequate armor, the resulting weapon would fundamentally change Pacific combat. Early American attempts at mechanized flamethrowers involved mounting portable flamethrower units in place of tank hull machine guns. The M3A1 Stuart light tank received this modification first, tested in combat on Bougainville in late January 1944. A stronghold of Japanese bunkers dubbed the Hornet's Nest became the testing ground. The modified Stuarts used both their 37mm guns and M1A1 flamethrowers to eliminate Japanese defenders. 28 large bunkers were destroyed, half credited to the flamethrower tanks. Approximately 80 Japanese were killed outside their bunkers, while an estimated 120 to 180 died inside, either shot, suffocated, or incinerated. The Bougainville action proved the concept but revealed limitations. The light tanks' armor couldn't safely engage the most heavily fortified positions. The bow-mounted flamethrower had restricted traverse, limiting tactical flexibility. The fuel capacity allowed only brief engagements, yet the results were promising enough to warrant further development. Development occurred not in established military research facilities, but in Hawaii. Schofield Barracks, May 1944. A top-secret composite unit assembled under Colonel George Unmacht of the Army Chemical Warfare Service, Central Pacific Area. Unmacht had been chemical officer in the Pacific Ocean area throughout the war, serving on Admiral Nimitz's staff. His 44 years of military service had taught him that innovations emerged from necessity, not bureaucracy. The Navy had ordered 5 Mark I flamethrowers in April 1944, intending them for some unspecified application. When they arrived in Hawaii, the Navy deemed them unsuitable due to excessive weight and turned them over to Unmacht's Chemical Warfare Service. Unmacht saw potential where others saw surplus equipment. He began with the 43rd Chemical Laboratory Company, the only unit immediately available. They modified an M3 Stuart light tank, mounting the flamethrower in the bow machine gun position. They designated it Satan. On April 15, 1944, Satan demonstrated its capabilities before officers from all services. Lieutenant General Holland Smith, known as the father of modern American amphibious warfare, immediately requested 24 Satans after watching the demonstration. The flame tank era had begun. Production required more than enthusiasm. Unmacht needed skilled technicians capable of complex mechanical and electrical work. The Marine Corps assigned men from the 5th Marine Tank Battalion. The Navy provided 25 Seabees from the 117th Naval Construction Battalion. These Seabees, construction specialists trained in welding, electrical work, and mechanical systems, proved essential to the project's success. The Seabees examined what the Army's Chemical Laboratory Company had created and concluded it was over-engineered. They simplified the design while maintaining functionality. The resulting tanks, nicknamed Satans, entered combat on Saipan in June 1944 during mopping-up operations. After operators gained experience, the tanks saw more action on Tinian, playing a lead role in overcoming Japanese strongholds. The Satan tanks proved the concept, but operators and commanders immediately recognized limitations. The M3 light tank's armor was inadequate against Japanese anti-tank weapons. The 37mm main gun was retained, but everyone recognized that a medium tank platform would provide better protection and more internal space for fuel storage. The Marines were requesting more flamethrower tanks, faster than the Hawaii facility could produce light tank modifications. By August 1944, requirements escalated dramatically. The 10th Army, forming under Lieutenant General Simon Bolivar Buckner Jr. for future operations, initially set requirements at 54 flamethrower tanks for the planned invasion of Okinawa. The Marine Corps, planning for Iwo Jima, requested additional tanks. Meeting these demands required upgrading to medium tanks of the M4 Sherman series. Colonel Unmacht's facility faced a resource crisis. Medium tanks were in short supply, prioritized for frontline combat units. The bureaucratic procurement process that governed standard military equipment would take months to authorize tank allocation for experimental modifications. Unmacht needed tanks immediately and couldn't wait for official channels. He negotiated directly with General Richardson of the Central Pacific Command and General Holland Smith of the Marine Corps. In the military politics of the Pacific Theater, this was dangerous ground. The Smith versus Smith controversy, where General Holland Howlin' Mad Smith relieved Army General Ralph Smith during the Marianas Campaign, had created tensions between Army and Marine commands. Wehrmacht managed to maintain positive relationships with both while securing the resources he needed. His ability to navigate command politics proved as crucial as his technical expertise. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late 1944, Wehrmacht's composite unit had expanded significantly. The original chemical laboratory company now worked alongside Marine tank specialists and Navy Seabees in an unofficial joint task force. Additional Seabees arrived as the 117th Battalion deployed to Saipan. Wehrmacht negotiated to keep the Seabees he needed in exchange for providing 8 M4 3 flamethrower tanks for the Iwo Jima operation. The challenge of mounting a flamethrower on a Sherman tank exceeded the light tank modifications by orders of magnitude. The M4's internal layout required complete reconfiguration to accommodate fuel tanks and the flamethrower system. The team worked to combine elements from 3 different flamethrower designs: the Canadian Ronson unit, the Navy Mark I, and components from those Mark Is the Navy had rejected. 2 Seabees, Machinist's Mate First Class A Reiche and Electrician's Mate Second Class Joseph Kissel, led the design work that produced the CBH-1 flamethrower system. The installation required 150 pounds of welding rod per tank. 1,100 electrical connections had to be made and tested. Each tank required 1,200 man-hours of labour and 150 custom-machined parts the Seabees had to manufacture locally. The cost per tank ranged from $20,000 to $25,000, equivalent to approximately $288,000 to $360,000 in 2019 values. The CBH-1 flamethrower operated at 300 pounds per square inch pressure, which gave it a range of 400 feet. The system could elevate from -12 degrees to +25 degrees and traverse 270 degrees. This represented a dramatic improvement over portable flamethrowers' maximum range of approximately 150 feet and far exceeded the early light tank installation's capabilities. The fuel tank held 290 gallons of napalm-thickened fuel. At typical flow rates, this provided substantially more operational time than the 7 seconds of burn time available from a portable backpack flamethrower. The weapon could be fired in controlled bursts, allowing the crew to engage multiple targets during a single fuel load. The engineering challenge wasn't just mounting a flamethrower. The weapon had to appear identical to a Presentio, standard 75mm gun Sherman from external observation. Japanese intelligence would naturally prioritize destroying flamethrower tanks if they could identify them. The solution was a false barrel that disguised the flamethrower nozzle. From a distance, the tank looked like any other Sherman in the Marine arsenal. The first 8 tanks, designated M4A3R3 or M4A3R5, depending on documentation standards, were completed by November 30th, 1944. The Fleet Marine Force had requested them on November 1st, with a delivery deadline just 30 days away. Wehrmacht's team met the deadline. 2 Seabees, Kissel and ship's fitter First Class J.T. Patterson, accompanied the tanks to oversee maintenance during the battle. Kissel would serve as an assistant driver-gunner with tank crews for 20 days of combat operations on Iwo Jima. The tanks shipped to Iwo Jima represented the cutting edge of mechanized flamethrower technology. The CBH-1 system was quickly improved to the CBH-2 specification, which extended range to 450 feet, though documentation sometimes refers to this as 150 yards, to avoid confusion with the feet measurement. The distinction mattered less than the fundamental capability. These tanks could project napalm farther and more accurately than any previous flamethrower weapon. The 8 flamethrower tanks landed on Iwo Jima on D-Day, February 19, 1945. They didn't enter combat immediately. The tank crews and Marine commanders needed to understand the tactical situation before committing their most valuable bunker-clearing assets. The tanks went into action on D+2, sparingly at first, as commanders assessed how best to employ them. The Marines quickly discovered what the Japanese already feared. Conventional firearms were relatively ineffective against defenders positioned in deep caves and reinforced bunkers. Grenades and satchel charges required infantry to approach within throwing distance, exposing them to devastating fire. Tank guns could suppress positions but rarely destroyed them completely. The flamethrower tanks offered something different entirely. The tactical employment developed through necessity rather than doctrine. Infantry would identify a fortified position holding up the advance. Standard tanks and infantry would provide suppressive fire, forcing Japanese defenders to take cover. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The flamethrower tank would approach as close as possible, often within 100 feet of the target. Then the crew would unleash napalm. The effect was both physical and psychological. The napalm stream reached into cave mouths and bunker-firing ports, following the contours of the fortification's interior. The flame consumed oxygen, suffocating defenders who might have survived the direct heat. The psychological impact on Japanese soldiers watching their positions burn was immediate. Some abandoned their posts rather than face incineration. One anonymous CB electrician's mate who operated a flamethrower tank during the battle documented the weapon's effectiveness. He wrote that his crew was assigned a pocket of resistance to burn out. They accomplished in 6 hours, with 4 loads of fuel, what a tank battalion and 3 infantry companies had been trying to achieve for 5 days. The mathematical efficiency of the flamethrower tank validated every hour of development work at Schofield Barracks. The tanks quickly became so valuable that Marines adjusted their entire tactical approach. Each Marine tank battalion on Iwo had only 4 flamethrower tanks. Rather than assign them to specific units, commanders pooled them at refueling locations. As different sectors of the battle required bunker-clearing support, the flamethrower tanks would dispatch from their base, complete their mission, return for refueling, then respond to the next request. Marines began holding up assaults until flamethrower tanks became available. The delay frustrated some infantry commanders who wanted to maintain momentum, but the casualties saved justified the wait. Attacking fortified positions without flamethrower support meant accepting casualties that might be avoided with proper support. The Marine Corps had learned brutal lessons about the cost of frontal assaults against prepared defences. The portable flamethrower units suffered catastrophic losses. One battalion's flamethrower teams sustained a 92% casualty rate, leaving few troops trained to operate the weapon. As portable flamethrower operators were killed or wounded faster than they could be replaced, the calls for mechanized flamethrower tanks increased. By the battle's middle stages, the Marines had become dependent on the tanks, fundamentally altering American tactics for the remainder of the campaign. Captain Frank Caldwell, a company commander with the 26th Marines, provided perhaps the most definitive assessment. He stated that in his view, it was the flame tank more than any other supporting arm that won the Battle of Iwo Jima. This wasn't hyperbole. The statistics supported his conclusion. The 8 flamethrower tanks consumed approximately 10,000 gallons of napalm every day of the battle. Each tank could carry 290 gallons, allowing multiple engagements before requiring refueling. The sustained operational tempo meant tank crews worked continuously, with maintenance performed under combat conditions by the Seabees who had accompanied the tanks from Hawaii. The Japanese response to flamethrower tanks revealed their terror of the weapon. Japanese soldiers attempted suicide attacks, specifically targeting the Shermans, trying to plant magnetic charges or throw explosives into the engine compartments. One tank from the 4th Marine Division received additional armour, 4 inches of concrete plating, specifically to counter magnetic charges. The tank also mounted a 50 caliber machine gun coaxial to the flamethrower to suppress infantry attempting to approach. The network of tunnels that made Iwo's defences so formidable became a liability when flamethrower tanks were involved. The flames and heat travelled through the tunnel systems, affecting positions far from the actual point of attack. The oxygen consumption in enclosed spaces meant defenders couldn't remain underground when flamethrowers were operating nearby. Japanese soldiers who might have survived for days in their fortified positions found themselves forced into the open, where Marine riflemen could engage them. The battle for Iwo Jima officially ended on March 26, 1945, after 36 days of continuous combat. Nearly 7,000 Americans died. Japanese deaths numbered approximately 18,000. Of the 20,000 to 22,000 Japanese defenders, only about 1,083 survived. The island that intelligence had estimated would fall in 1 week had consumed over a month of the fiercest combat in Marine Corps history. The flamethrower tank's contribution to victory couldn't be measured solely in bunkers destroyed or casualties inflicted. The weapon provided Marines with a capability they had lacked: the ability to reduce fortified positions without accepting unsustainable infantry casualties. The psychological impact on both sides was equally significant. Marines gained confidence knowing they had effective support against the strongest defenses. Japanese defenders lost the assurance that fortifications guaranteed survival. The lessons from Iwo Jima immediately influenced preparations for the next operation. The 10th Army, preparing for the invasion of Okinawa, had already ordered 54 flamethrower tanks. The entire 713th Tank Battalion would provisionally convert to flame configuration. The battalion was tasked with supporting both Army and Marine Corps assault forces, reflecting the weapon's proven value across service branches. The Seabees at Schofield Barracks supervised officers and enlisted men from the 713th as they converted all 54 of their tanks. These used the Ronson flamethrower system rather than the CBH models, a different design configuration but proven effective. The Ronson had less range than the CBH-1 or CBH-2, but simplified logistics and maintenance considerations made it acceptable for large-scale production. In June 1945, the 43rd Chemical Laboratory Company achieved another breakthrough. They developed stabilized flamethrower fuel, an improved napalm formulation that provided better range and target effects. The Seabees oversaw construction of an activating plant that produced over 250,000 gallons of this improved fuel. The 713th Tank Battalion consumed 200,000 gallons during the Okinawa campaign, demonstrating the massive scale of flamethrower employment in Pacific operations. Also in June, the Army cancelled all further production orders for M4 Sherman tanks. The war in Europe had ended, and production priorities were shifting. However, the Under-Secretary of War, Robert Patterson, recognized the flamethrower tank's critical importance for the planned invasion of Japan. He placed an expedite order on Colonel Unmacht's production facility, granting it AAA procurement priority, the same priority level assigned to the B-29 bomber program and the atomic bomb project. The Marine Corps ordered 72 additional flamethrower tanks for the invasion of Japan. Unmacht's crews completed 70 by victory over Japan Day. In total, the flame tank group at Schofield Barracks produced 354 tanks during the war. Every mechanized flamethrower tank used in the Pacific Theater came from this single facility, modified by Army, Chemical Warfare Service personnel, Navy Seabees, and Marine tank specialists working in joint cooperation. The after-action reports from both Iwo Jima and Okinawa confirmed what Captain Caldwell had observed. Army assessments stated that flamethrower tanks had a psychological presence on the battlefield. American troops preferred to follow flamethrower tanks over standard armor because of the fear the weapons instilled in enemy forces. Japanese prisoners, when questioned, consistently identified flamethrower tanks as the weapon they feared most. Marine Corps Medal of Honor recipient Herschel Woody Williams provided the infantry perspective on flamethrowers. Williams, using portable flamethrowers during the battle, spent 4 hours destroying Japanese pillboxes on Iwo Jima, returning to his lines 5 times for fresh weapons and 5 times returning to combat. His actions enabled American tanks to advance and create pathways for infantry. Williams survived, but he lost his best and friend, Vernon Waters, his assistant flamethrower operator during the battle. The portable flamethrowers remained essential, but the casualty rates never became acceptable. The mechanized flamethrowers didn't eliminate the need for portable units. Infantry still required man-portable weapons for situations where tanks couldn't reach or where tactical circumstances demanded immediate action. But the survival rate for tank crews versus portable flamethrower operators demonstrated the value of armor protection. Tank crews could repeatedly engage enemy positions and return to fight again. Portable flamethrower operators often didn't survive their first engagement. The technical specifications that made flamethrower tanks effective weren't classified after the war. The range of 400 to 450 feet, the fuel capacity of 290 gallons, the pressure systems operating at 300 pounds per square inch. These details entered military literature, have influenced post-war development. But the specifications alone don't explain the weapon's impact. What made flamethrower tanks decisive was the combination of factors. The armor protection allowed crews to approach fortified positions. The range exceeded enemy small arms, effective distance. The fuel capacity enabled sustained operations. The psychological effect on defenders multiplied the physical damage. And critically, the tanks were available when and where commanders needed them, produced in sufficient numbers to support major operations. The victory at Iwo Jima, purchased at such terrible cost, vindicated the flamethrower tank concept. American casualties were high, but they would have been catastrophically higher without the mechanized flamethrowers. The fortress Kuribayashi had built wasn't impregnable. It just required the right weapons, employed by crews trained in their use, supported by infantry and conventional tanks working in coordination. The flamethrower tanks that fought on Iwo Jima and Okinawa represented American industrial improvisation at its finest. Colonel Unmacht and his composite team of Army, Navy, and Marine personnel had created, from available components and local manufacturing capability, a weapon that changed Pacific combat. They did it outside normal procurement channels, working with surplus equipment the Navy had rejected, modifying tanks that weren't officially allocated for the purpose. The story of American flamethrower tanks isn't primarily about technology. It's about adaptation. Recognizing that conventional weapons couldn't solve the problem of fortified Japanese positions. Understanding that portable flamethrowers worked but killed their operators. Combining the protection of armored vehicles with the bunker-clearing capability of flame weapons, and executing that vision fast enough to affect combat operations while the war was still being fought. The legacy of these flamethrower tanks extended far beyond the volcanic sands of Iwo Jima. The weapon that had proven decisive in 1945 would continue influencing American military doctrine and operations for years to come. The lessons learned from those 36 days of combat shaped not just tank development, but fundamental approaches to fortified position warfare. When the Korean War erupted in June 1950, the Marine Corps found itself facing familiar challenges. North Korean and Chinese forces, like the Japanese before them, understood the value of fortified positions and underground tunnel networks. The Marines remembered what had worked on Iwo Jima. They assembled 9 flamethrower tanks from the remaining wartime inventory stored at Camp Pendleton and Hawaii. Out of the 26 flame tanks the Marine Corps had received during World War II, enough survived in serviceable condition to form a combat unit. The unit was designated the Flame Dragons, a platoon attached to headquarters of the 1st Tank Battalion. The name reflected both the weapon's nature and the psychological impact Marines hoped to achieve. These tanks represented continuity with the Pacific War, a proven weapon system being deployed against a new enemy in a new war. The Flame Dragons landed at Incheon on September 15, 1950, part of General Douglas MacArthur's audacious amphibious assault behind North Korean lines. The flamethrower tanks advanced in the second wave on Womedo Island, providing the same bunker-clearing capability that had proven essential on Iwo Jima. They participated in the First Battle of Seoul, employing tactics developed 5 years earlier against fortifications that differed in detail but not in fundamental challenge. The weapon that had terrorized Japanese defenders in the caves of Iwo Jima proved equally effective against North Korean bunkers and Chinese tunnel complexes. The range that allowed engagement beyond small arms effective distance, the napalm that followed, fortification contours, the psychological impact of approaching flame, these factors transcended specific enemies or terrain. The Flame Dragons became the only American mechanized flame unit to serve in Korea, a testament to both the weapon's effectiveness and the limited number of tanks still operational. The technology that Colonel Unmacht and his Seabees had developed eventually became obsolete, but not quickly. It wasn't until 1955, a full decade after the war's end, that upgraded flamethrowers mounted in M67 tanks finally replaced the Sherman-based systems. For 10 years, from Bougainville in 1944 through Korea in 1951, the mechanized flamethrowers produced in that converted warehouse at Schofield Barracks remained America's primary bunker-clearing weapon in armored warfare. The human cost of Iwo Jima cannot be separated from the story of the weapons that won the battle. The statistics remain staggering even decades later: nearly 7,000 Americans killed, approximately 20,000 Japanese dead, 27 Medals of Honor awarded, more than any other single battle in American military history. 12 of those medals were specifically for efforts in eliminating enemy positions, for actions that required men to approach fortified bunkers and caves, despite knowing the odds against survival. Only 6 of those 12 men survived to receive their medals. The others died in the attempts that earned them recognition. Their courage, whether carrying portable flamethrowers or crewing tanks or assaulting positions with grenades and satchel charges, exceeded calculations of risk and reward. They fought because their units needed those positions cleared, because Marines behind them couldn't advance until the bunkers fell, because the mission demanded it regardless of personal cost. The fortress that Lieutenant General Kuribayashi built on Iwo Jima demonstrated what determined defenders with adequate preparation time could achieve. The 11 miles of reinforced concrete tunnels carved into volcanic rock represented months of engineering labor. The hundreds of fortified positions, each supporting the others through interconnected fire lanes and tunnel access, showed sophisticated defensive planning. The integrated network, where cleared bunkers could be immediately reoccupied through underground movement, revealed tactical innovation that challenged American doctrine. American victory on Iwo Jima wasn't inevitable. The island could have become another Tarawa, where American casualties approached or exceeded Japanese losses, where victory's cost raised questions about strategic wisdom. The availability of flamethrower tanks, weapons specifically designed to overcome fortified defenses, changed those calculations. The tanks didn't eliminate casualties, they reduced them to levels that, while terrible, remained acceptable within the logic of total war. The 8 flamethrower tanks that landed on D-Day carried more than napalm and compressed nitrogen. They carried months of development work by Colonel Unmacht's composite team. They carried thousands of hours of skilled labor by Seabees who welded, wired, and machined components under deadline pressure. They carried the desperate hope of Marine commanders who understood that portable flamethrowers alone couldn't clear Iwo Jima without unsustainable casualties. Captain Frank Caldwell's assessment that flame tanks more than any other supporting arm won the Battle of Iwo Jima wasn't exaggeration or service pride. It was recognition of battlefield reality. The Marines who watched flamethrower tanks burn out positions that had resisted days of conventional assault understood the weapon's value. The Japanese defenders who abandoned fortifications rather than face incineration demonstrated the psychological impact. The statistics showing reduced American casualties in sectors where flamethrower tanks operated proved the tactical effectiveness. The question this story began with asked how American engineers created a weapon that made the Japanese fortress of Iwo Jima vulnerable. The answer reveals itself through examining not a single innovation, but an entire system. Colonel Unmacht's political skill in securing resources from competing commands, the Seabees' technical expertise adapting equipment the Navy had rejected, the willingness to work outside official procurement channels when bureaucracy threatened to delay critical capabilities, the integration of Army Chemical Warfare Service, Navy construction battalions, and Marine Corps tank specialists in joint operations, before such cooperation became standard doctrine. The flamethrower tanks that shot fire 150 feet across Iwo Jima's volcanic landscape didn't make victory easy or cheap. They made victory possible at a cost America could sustain. In caves and bunkers where Japanese defenders thought of themselves safe, where concrete and volcanic rock provided protection against artillery and bombs, the napalm reached. The tunnels that should have allowed flexible defense became conduits for flame and heat. The fortress Kuribayashi, designed as his masterpiece, became his tomb. The Marines who fought on Iwo Jima, who watched those Sherman tanks approach enemy positions and unleash fire, who advanced behind that protective flame to secure ground purchased in blood, understood a truth that transcended after-action reports and medal citations. Without those tanks, without that weapon, without the fire that turned Japanese advantages into liabilities, the black volcanic sand of Iwo Jima might never have flown an American flag. The weapon worked, the fortress fell. The cost, though terrible, remained within the boundaries of what total war demanded and what America proved willing to pay. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.